Good afternoon, everyone. Oh, we're waiting for Charles. Seems justified. Here he is. Here he is. Yeah. There he is. Okay. So again, good afternoon, and welcome to this session, the third one in the colloquium. Our speaker, distinguished speaker, Professor Michael Friedman from Stanford University. It's an honor and a pleasure for me to introduce him. I think it's an easy person to introduce because everyone knows him around here. Nevertheless, I think I should mention some of his latest publications. I just saw that there is a brand new one, Kant's Construction of Nature, a reading of the metaphysical foundations of natural science. This is 2013, you know about it. And another one that I'm sure will be as interesting as the previous one. I can mention the Cambridge Companion to Carnap, the Kantian Legacy in the 19th Century Science, Dynamics of Reason, the 1999 KANT Lectures at Stanford University, and so on and so forth. And the talk today will be on From Intuition to Tolerance in Carnap's Philosophy of Mathematics. We have some handouts, so if you need. If anyone needs, please raise your hand and we will.
Okay, well, everybody have a handout? Good. It could be useful because sometimes you can't really see too far down on the screen. I'll try to tell you which one I'm at because I'll have a lot of these quotations also on the screen. So it's a great honor and a pleasure for me to be here in this conference in honor of Charles Parsons. I feel that I'm a kind of student of Charles, even though I wasn't ever an official student of Charles, he made a tremendous difference to me and to the way my career has gone. Basically, the first 10 years or so after I got my PhD, I was working in contemporary philosophy of physics and philosophy of science. There were little hints of historical ideas, but it wasn't primarily historical scholarship, and certainly not of Kant. So around 1980, reading a book by Geert Buchdahl, who talks about the importance of Kant's science for his general philosophy and its historical context in the early modern period in relation to science and philosophy, made me think there was something I could really do with that. Taking a historical approach to Kant's philosophy of mathematics and science, not trying to defend it as true or false, but trying to see what it meant in the context of its time. So I had that idea, but I didn't really know how to do that kind of history. I didn't really have a model. My first ideas were about Kant's philosophy of geometry. So I thought, well, I know Charles Parsons has written on this. And Charles Parsons is a terrific philosopher of mathematics. And so I started reading, and of course I read Hinticke and others in Beth. But it was from Charles that I think I had a model of how to do historically oriented philosophy of mathematics and philosophy of science, which is sensitive to the context of the time philosophically, to what is happening mathematically at the time, what was the person thinking about or engaged with mathematically, and also one which looked at the texts using the traditional methods of scholarship, but with this wider context of the philosophy and the science of its time. And no one did that better than Charles, by my money, and in his work on Kant's philosophy of mathematics, I saw a model of that, even though I didn't agree with everything Charles said. And it was without that I would not have, and since then I've been basically doing this kind of historically oriented philosophy of science and mathematics. And I don't think I could have been, as it were, set on the secure path of doing that without Charles's example and inspiration. Now, I'm not going to talk about Kant. Some of you will be happy to know we had a lot of Kant this morning, and I said a lot about Kant. But I'm actually going to be talking about Rudolf Carnap, as the title suggests, who is a figure that Charles has not particularly treated in the 20th century. So why am I doing that? Well, what I'm interested here in this talk is Kant's place in discussions of foundations of mathematics, and as we'll see also of science more generally, in the early 20th century, and how what he had to say about philosophy of mathematics was located there. Now, of course, everyone knows that Frege was his teacher, and so he has that great example. So Frege is a person that Charles talks about. Carnap had interactions with Gödel. That's a Charles person. It's less well known, maybe better now than it was, that Kant also had very significant relations to Kantian philosophy, which had a effect on his philosophy of mathematics and science, and also to Edmund Husserl. And so that'll be a part of my story as well. So I'm hoping to locate Carnap within Charles's world, if you like, of foundations of mathematics and science in the 20th century. We'll see, I think, why he's not someone that Charles and other people seriously interested in foundations of mathematics give a central role to. And I'm hoping that by putting Carnap in this context, it'll help to see how, even though Carnap is not doing foundations of mathematics in that sense, one really should take what he's doing into account because of his central role in the whole wider context. Okay, enough of that. So I want to discuss a sequence of episodes in Carnap's thinking about mathematics, beginning with his doctoral dissertation, Der Raum, 1922, which represents the most explicitly Kantian episode in his thought, proceeding to some developments leading from there up to the Aufbau, 1928, then turning to the logical syntax of language, 1934, where the principle of tolerance, that's part of my title, is first officially formulated, and finally considering some episodes in his thinking from the following semantical period, as it's called, and beyond. I should caution you at the outset, however, about possibly misleading implications of my title, From Intuition to Tolerance. For I do not mean to imply a transition from a doctrinal commitment to a central role in the epistemological grounding of mathematics to some kind of intuition, whether Kantian, Husserlian, Brauerian, or Gödelian, in Carnap's work, to a more relaxed and pluralistic approach involving a tolerant appreciation of a variety of epistemological strategies. Nothing could be further from the truth. For Carnap is just as tolerant in this broad sense in Der Raum, and indeed in everything he does, the main point of which, Der Raum, is to argue that logical and formalistic approaches to space and geometry, as in Russell and Hilbert, empirical or physical approaches, as in Helmholtz or especially Einstein, and intuition-based approaches in the Kantian, Neo-Kantian, and Husserlian traditions, all have an important element of truth. It is just that these three different approaches for Carnap are talking about three different types or meanings, as he puts it, of space, namely formal, physical, and intuitive space. And although Carnap abandons the idea of intuitive space, that's the most Kantian element, in the sense of Der Raum by the time of the Aufbau, he preserves important aspects of Kantian and Neo-Kantian epistemology in this work and even well beyond it. So that Kantian impetus, which Husserl plays a role in for Kant, continues beyond when he officially abandons what he takes to be Kantian intuition. We get a better sense of Carnap's characteristic approach to the philosophy of mathematics and to philosophy more generally if we take seriously his claim that, throughout his career, he actually held no philosophical positions in the usual sense at all. Now referring to questions 1, 2, 3 on the handout, and I'll look at them on the screen, from his intellectual autobiography. He's describing how his views evolved. So here is the first one. He had friends that he talked philosophical issues with, but when he was working on the Aufbau, he became aware that in talks with these friends, he used different, what he calls, philosophical languages, adapting myself to their ways of thinking and speaking. With some at the bottom, I would talk a language which might be labeled nominalistic. With others, again, Frege's language of abstract entities of various types, a language which some contemporary authors call Platonic. And in the second quotation there, when asked which philosophical position I myself held, I was unable to answer. This is pure Carnap. My way of thinking was neutral with respect to the traditional controversies, e.g. realism versus idealism, nominalism versus Platonism, realism of universals, that's the kind of Freudian view, materialism versus spiritualism, that is dualism, and so on. And then finally he mentions logical syntax. This neutral attitude toward the various philosophical forms of language was formulated as principle of tolerance in logical syntax, and I still hold it today, e.g. with respect to contemporary controversy about a nominalistic or Platonic language. And there I think, and we'll see in a moment, he's referring to controversies with Quine about quantifying over abstract entities. Now, if we look at some of the debates in the philosophy of mathematics that Carnap participated in, we see that his claim to neutrality and not having a position seems to be quite true. Or rather, he changes whenever depending on who he's talking to. Thus, during the early 1930s, when he was working in logical syntax and engaged in serious discussions with Gödel, we see that Carnap's approach, especially in comparison with Gödel's, can be described as nominalistic as opposed to Platonic. For Carnap simply takes it for granted that the only scientifically meaningful existence assertions are those concerning physical objects in space and time. The entire set theoretical or type theoretical hierarchy of natural numbers, sets of natural numbers, and so on, is simply for Carnap a more or less convenient device for setting up a mathematically tractable coordinate system for representing whatever spatio-temporal magnitudes, mass, charge, the electromagnetic field, and so on, there happen to be. And there is no substantive question for Carnap concerning whether one or another mathematical representative of such physical entities in the hierarchy really exists. Nevertheless, when Carnap is responding in Empiricism, Semantics, and Ontology to the explicitly nominalistic philosophical predilections of Goodman, Quine, and Tarski, who he was in debates with 10 years earlier, Carnap rather defends the system of abstract entities, that is, natural numbers, assumed in standard Peano arithmetic. That is, he defends what he takes to be a Platonic, in a sense, Carnapian sense, as opposed to a nominalistic form of language in the sense of quotation 3 about logical syntax. Okay. With these preliminary cautions understood, I will begin my narrative with Der Raum, which, as suggested, involves the most explicit appeal to the Kantian conception of spatial intuition in all of Carnap's works. It represents the final product, in particular, of Carnap's studies at the University of Vienna with the neo-Kantian philosopher Bruno Bauch. This is quotation 4 here, in case you had trouble seeing the bottom, describing how he took a seminar on the critique of pure reason for a whole year with Bruno Bauch. I was strongly impressed, Carnap says, with Kant's conception that the geometrical structure of space is determined by the form of our intuition. The after effects of this influence was still noticeable in the chapter on intuitive space in his dissertation, Der Raum, and actually I'm going to show it's still traceable, although in attenuated form, really throughout his career. The first chapter, yes, so there are 3 chapters, formal, intuitive, and physical space. The first chapter on formal space of Der Raum begins with an exposition of logic following Carnap's most important teacher at Vienna, Gottlob Frege, and then turns, as suggested, to an exposition of both axiomatic and what we now call set theoretical or type theoretical developments of the purely formal structure of space, using heavily the theory of relations of Principia Mathematica. So there's not only a Freudian but a Russellian influence, although the conception of logic seems closer to Frege. But it is in the second chapter on intuitive space that Carnap attempts to modify the original Kantian, globally Euclidean structure of our form of outer spatial intuition in order to accommodate the use of non-Euclidean geometry of variable curvature in Einstein's theory of general relativity. That's a main target. So he wants a notion of intuitive space, but he wants it to still be tenable in Einstein's universe. The centerpiece of the second chapter on intuitive space is Carnap's modification of Hilbert's axiomatization of Euclidean geometry. Carnap takes Hilbert's axioms of incidence and order correctly to describe the necessary a priori structure of any limited or local region of space as immediately presented to us, Carnap says, in Husserlian Wesenserscheinung. And so he puts together a Kantian notion of intuition with Husserlian Wesenserscheinung. When it comes to the metrical structure, however, Carnap reformulates Hilbert's axioms of congruence and parallels via a limiting procedure, so that specifically Euclidean geometry, following Riemann, is valid only in the very smallest regions, not even locally, that is, infinitesimally. The global structure of space, finally, can be determined only by what? So we have the infinitely small, the infinitesimal, we have the small but finite, the local. The global structure can be determined only by what Carnap calls postulates, Forderungen, which stipulate how the logical and infinitesimal structures fit together within a single comprehensive spatial structure. These are to be chosen by convention, but with an eye toward what is most convenient in physics. Carnap chooses these postulates in such a way as to allow maximal but continuous variability in the curvature from point to point, so as thereby to prepare the way for the accommodation discussed at length in the third chapter on physical space of Einstein's use of a semi-Riemannian geometry of variable curvature to represent the gravitational field. Before we're proceeding to this third chapter, however, I should observe that there is a fundamental problem with Carnap's modification of Hilbert's axioms. In particular, Hilbert's axioms of incidence and order, his axioms of incidence, are not even locally valid in general in a three-dimensional Riemannian manifold. Consider Hilbert's axiom 1.6. If 2 points of a line lie in a plane, then every other point of the line lies in the same plane. So what I'm trying to show here is a counterexample to that in a three-dimensional Riemannian manifold. The idea is that this curved thing is one plane. P, Q, and R are all in that plane. But Q and R, if you connect them by a geodesic, you're on something like this, which is not on the same plane. So these 2 points lie in this plane, this curved one, but the geodesic connecting them does not lie in this plane. How does that happen? Well, what is a plane in one of these three-dimensional Riemannian manifolds? Well, the one I've drawn that contains P, Q, and R, what you do is you take a point P, it's defined on the neighborhood of a point P, the notion of a plane. And so you have a tangent space at P, three vectors linearly independent at this point. And a plane is a family of geodesics, so Q and P and R are geodesics that are part of this plane. And then you consider all of them that are tangent to a certain two-dimensional subspace of the tangent space at P, and that's what a plane is. Now, this gives you an idea of why when you go to Q or R, even though they're on the same plane, planes through them now have to be defined relative to tangent spaces at Q and R. And then the relevant geodesics are going to be defined relative to those planes that are, as it were, projections of those two-dimensional tangent spaces. And so it can easily happen that there's going to be a geodesic there, which is not in the same place. So, of course, these are on the same geodesic, Q and R on the same geodesic, that's fine, the axiom holds for them. But Q and R are on that plane, and since now they're defined relative to a different local planes in this sense, defined for this point or this point, they don't have to lie the same. So really the problem here is that it's not, I'll get to the next sentence and then I'll say what the problem is in general. So the third chapter of Der Raum on physical space, so really Carnap has no choice but to take all of Hilbert's axioms, not the metrical ones, but even the axioms of incidence and order, as holding only infinitesimally, not locally. The third chapter of Der Raum on physical space undertakes to treat intuitive space as a Kantian form of intuition in a generalized sense. This generalization is mediated, and of course the point is to generalize Kant so that Einstein is going to fit into this. This generalization is mediated by a central distinction between what Carnap calls freely chosen or optional wahlfreie form and necessary or notwendige form, where only local topological structure, of course, comprehends the facts of perceptual experience within necessary form and thereby presents them uniquely, independent of the freely chosen metrical stipulations that are laid down by convention. In this way, the immediate deliverances of Husserli and Wesenserschauung provide our perceptual experience with the structure of a form of intuition in something like the original Kantian sense, but the intuitive space in question is compatible with all possible Riemannian structures. And now what that is delivered to you by Wesenserschauung is just a local topology. Right? While if you add the axioms of incidence and order, you're also saying that the local projective structure, or affine structure, is similarly going to be equivalent no matter what the metrical structure is in such a manifold. And that's just not right. So you have local topological equivalence, but you don't have local invariable curvature, projective, or affine equivalence. There's a reason why Carnap made this mistake, and if anyone's interested, we can talk about that in the questions. People were not clear about that, and he wasn't. Okay. If we want a single spatial structure containing all of these possible optional determinations, that is metrical ones, therefore we adopt n-dimensional topological space, but no particular one of the infinity of possible n-dimensional metrical spaces. The reason that he picks n-dimensional rather than say 3 is that the local deliverances of topology just tell us, if you like, that there's at least 3 dimensions. But it doesn't tell you that there are any more dimensions when you go to the global structure, but that global structure has to be put together by convention in light of what is convenient in physics, and so we can't anticipate a priori that. Right, so that's why it says the only thing you can say a priori is that n-dimensional topology, maybe for n greater than or equal to 3, is given to us intuitively. While necessary form comprehends the topological spatial features that are intrinsically present in our form of spatial intuition, optional form comprehends the additional metrical spatial characteristics that are not built into our a priori spatial intuition at all, but are nonetheless also indispensable in physics via a freely chosen metrical stipulation for mathematically describing the facts of experience. Because we're not going to just do topology to do physics, we have to measure stuff and have a metric. Okay. The generalized Kantian distinction between necessary and optional form articulated in Der Raum also figures centrally in Carnap's 1924 paper, Dreidimensionalität des Raumes und Kausalität. Carnap begins here by distinguishing between what he calls experience of the first level and experience of the second level, between primary and secondary worlds, insofar as the first level experience is subject to a univocal or necessary formation, notwendige Formung, whereas the second subjects this univocal structure to a further non-univocal reformation, Umformung. The distinction depends in particular on, quote, this is my new handout from Carnap's paper, on the necessity, Notwendigkeit, of the forms of the first level and the freely chosen character, Wahlfreiheit, of the forms of the second, which is manifested by the presence of different types of secondary worlds. There's, as it were, only one structure for the primary world, but there are different possible structures that then have to be chosen for the secondary world. The most important of these different structures are the various mathematical forms for the world of physics considered in his 1923 paper, Über der Aufgabe der Physik. Yet the 1924 distinction between primary and secondary worlds introduces an important new element that's not present in Der Raum at all. A transition from 2 to 3 dimensions in the respective spaces of the two worlds. The space exhibiting necessary form now for Carnap is not 3-dimensional intuitive physical space, as in Der Raum, but rather the 2-dimensional topological space of the visual field. The 1924 paper thereby introduces a further epistemological problem, depicting the route from private subjective experience, the primary world, to the external physical world, which will be taken up and developed. In the Aufbau, however, there is no remaining trace of the notion of necessary perceptual form, and thus no remaining trace, I'm actually putting this too strongly because I want to say there is a remaining trace, but not of necessity and synthetic a prioricity. But I'll say it now, no trace of either Kantian spatial intuition or the synthetic a priori, that's the key. And here are some things he says about it. He distinguishes in the Aufbau, there are two things you can do. You can constitute in this type theoretical harmony, this hierarchy that starts with the elementary experiences, defining various properties and dimensions, that is sets and sets and sets and sets of elementary experiences. And then what you can do is find out stuff about the things that you've defined, say about atoms or about the electromagnetic field. According to the conception of constitutional theory, there are no other components of cognition besides these two, the conventional and the empirical, and thus no synthetic a priori. This is quotation 6. What Carnap has in mind is that I guess 6 and 7. What Carnap has in mind is that every constituted object is supposed to be set theoretically or type theoretically defined in a finite number of steps on the basis of the elementary experiences comprising the first level of the iterative hierarchy of constituted objects. Once the object has thus been defined, there remains only the infinite but empirical task of scientifically investigating its non-constitutional, that is, empirical properties. Thus, Carnap's rejection of the synthetic a priori here essentially involves a crucial modification of the so-called genetic, or Zoikende, conception characteristic of the Marburg school of neo-Kantianism. They have this idea of the eternal X, that you never can actually define the object of experience in any finite number of steps. It's really a regulative idea of reason that you can just approximate. And that is connected with their attempt to retain some element of Kantian synthetic a priori, although they actually give up the Kantian notion of intuition as a separate faculty. So he's saying in opposition to this, finitely many determinations suffice for the constitution of the object, and thus for its univocal description among the objects in general, again, whose complete description remains an incomplete element. So here, his opposition to the Marburg school is one of the ways in which he cashes out his argument against any kind of Kantian or neo-Kantian synthetic a priori. And for him, the most characteristic members of the Marburg school are Paul Natorp and Ernst Kessier, the two most important students of him and Cohen. I say modification because Carnap by no means rejects this version of neo-Kantianism completely, even though he doesn't buy the synthetic a priori. On the contrary, he is perfectly happy, in accordance with his general attitude of tolerance concerning epistemological questions in the Aufbau, explicitly to acknowledge what he, Carnap, takes to be the significant epistemological theses that he shares with them, with this school. Here I have two from the Aufbau. Positivism is good because it stresses that all the material of cognition is undigested empirical given. These are the basic elements. Transcendental idealism, however, especially the neo-Kantian tendency. Rickert, who was the Southwest School, Kessier, Marburg School, Wald, his teacher, student of Rickert, has rightly emphasized that these elements do not suffice. Order posits must be added are basic relations. So they both have an element of truth. In particular, although Carnap rejects the Marburg commitment to the synthetic a priori, he agrees with their genetic conception. Here he puts in idealistic language, are generated in thought, in denken erzeugt. The constituted objects are only objects of cognition qua logical forms constructed in a determinate way, emphasizing again the amorticity by his lights of this element of constitution. So this is what he takes himself to be borrowing from the best technical idealism of the time. So although Carnap rejects the markedly committed to the Semitic a priori, he agrees with their genetic conception against what he takes to be overly crude versions of empiricism, positivism, Mach, say, that the characterization of empirical objects via logical forms is essential to their proper scientific cognition. And logical forms for him are certainly a priori, although analytic a priori. In sum, the only a priori experience constituting elements that Carnap now accepts in the Aufbau are formal logical ones. And for space in particular, the only such elements that he now accepts are those which in der Raum he took to be elements of formal space, not intuitive space. Thus, in the Aufbau, Carnap constructs what he calls the perceptual world, and then the world of physics by beginning with R4, a purely numerical structure, but embedding some perceiver, some Kantian, some Carnapian, I often have to slip, some Carnapian subject with its elementary experiences into this R4, which is just a real number space. But we can embed ourselves into that, and then once we do that, we can embed sensory qualities that are in the autopsychological realm, that is in my elementary experiences, colors, into this world, that is the R4 world, the space-time world, along spatial lines of sight, as it were, and you get this, the perceptual world. And finally, assigning mathematical representatives of various physical magnitudes, scalar fields, vector fields, and so on, the electromagnetic field, which are representative of various physical magnitudes. There I have the electromagnetic field tacked on to the color surfaces. Because we know that what's really causing that is the wavelengths. And this is what Carnap calls the physico-qualitative coordination. So the complete physical world is going to start with R4, but then embed these perceptual qualities, if you like, into it. They're not reduced to abstract things. They're themselves in a way primitives, or at least they're defined by the primitive relation between elementary experiences of partial similarity in some respect. Moreover, in accordance in this respect with the conception of der Raum, only the topological structure of R4 counts as experience constituted in Carnap's construction. Because both the division of R4 into representatives of three-dimensional space and one-dimensional time, and the metrical properties of both space and time remain to be determined by a combination of experience and convention. So they're not part of the experience constituting necessary forms. Nevertheless, while space and time for Carnap are thereby represented by purely formal, purely analytical mathematical entities in terms of the spatio-temporal coordinate system, R4, and then the scalar and tensor fields and so on, although they are constitutionally, on the contrary, they are represented by purely formal entities, but they are no means identified with such purely formal entities. On the contrary, space and time themselves are constitutionally introduced as essentially perceptual and in this sense intuitive, as what we might call perceptual space and time. So you don't have space as opposed to R4, that is spatial world in which we live in, until we embed us and our perceptions into it. And then you build physical space on top of that. So both perceptual space and physical space have an essentially perceptual, that is, intuitive element, an empirical intuitive element, which decisively distinguish them from just an analytical science of R4 and analytical fields defined on it. For Carnap in the Aufbau, there therefore remains a crucial asymmetry between his conception of arithmetic and analysis on the one side, which are purely formal and analytic, and his conception of geometry, both spatial and spatio-temporal, on the other. And this asymmetry, as we shall see, persists throughout his career. This is what I mean by the attenuated remains of intuitive space. Of course, it's not going to be a priori anymore, but we'll get there. Carnap's serious engagement with what we now call the philosophy of mathematics, and in particular with what we now call the foundations of mathematics, and what Carnap himself called the foundations of mathematics, begins in the next phase of his career, culminating in the publication of Logical Syntax in 1934. This phase begins, as Carnap makes clear in his autobiography, with a famous lecture Brouwer presented in Vienna in 1928. This is your quotation number 10, which I put up here, but you're going to have trouble with the last sentence, so you're not going to look at it. Brouwer came to Vienna and lectured to the Vienna Circle. The empiricist view of the circle was, of course, incompatible with Brouwer's view, influenced by Kant, that pure intuition is the basis of all mathematics. Boo. Nevertheless, the last sentence, the constructivist and finitist tendency of Brouwer's thinking appealed to us greatly. Indeed, one can well understand why Carnap and the Circle were attracted to these constructivist and finitist tendencies, because they dovetail nicely with the finitist conception of the principle of verifiability that the Circle found in both Wittgenstein's Tractatus and quite explicitly in Carnap's Aufbau. So here from the Aufbau, I tried to shorten this, but it didn't quite work out. But the crucial point is, since there's only a finite number of steps to constitute any object that you then want to test, what you're going to do is you're going to test any proposition by running through the basic relation, the basic elements, and there's always a finite number of those, he thinks. And then, in a finite number of steps, those basic elements are going to define whatever properties and relations you need. And so, in principle, it's possible in a finite number of steps to verify whether the state of affairs, the properties holding of whatever the object is, obtains or not. Now, there's a problem with this because some of his definitions are highly non-predicative. And if you want, we can talk about that in the discussion. But he's not concerned with that now, although he does become concerned with it later when he's trying to defend logicism in 1931. But anyway, he had a finitist constructivist picture of verification in the Aufbau, which helps to explain what he liked in Brouwer. Despite these attractive features of Brouwer's intuitionism, however, neither the Vienna Circle nor especially Carnap could long rest content with Brouwer. The most fundamental problem, especially in Carnap's case, was that to go along with Brouwer was to become entangled with the crisis in the foundations of mathematics, as it was called, that embroiled some of the leading logicians and mathematicians of the time. The immediate stimulus for this crisis were worries about the consistency of classical mathematics in the wake of the logical and set theoretical paradoxes that gave rise to three mutually opposing schools of thought. Formalism, represented by Hilbert and Bernays, attempted to save classical mathematics and logic by developing a formal consistency proof using only limited or finitistic methods. Intuitionism, by contrast, represented by Brouwer and Hayting, mounted a revolutionary challenge to classical mathematics and logic based on a rejection of the law of excluded middle applied to quantifications over infinite collections. And logicism, finally, attempted to preserve as much as possible of the original Frege-Russell conception of logic and mathematics in the context of the more radical proposals of both the intuitionists and the formalists. It was Carnap himself who represented the logicist position at a defining symposium he organized under the auspices of the International Congress of Physicists and Mathematicians at Königsberg in September 1930. And this is the thing that famously occurs in translation in Benacer and Putnam to introduce this threefold classification of logicism, formalism, and intuition. And this was a workshop organized by Carnap and Reichenbach. Reichenbach was more important at the time, so Carnap's name is in smaller letters. And here you see the three papers, the logical foundation, the intuitionist foundation, and the formalistic. Carnap defending the logical. The other two represented by Hayting and Van Neumann. Even here, however, in that paper, you go back and look at it in the Benacer and Putnam, Carnap clearly, and it's totally about impredicativity, Carnap clearly indicates at the end of his contribution that logicism, in his sense, needs to incorporate the valid insights of both formalism and intuitionism. So it's a pretty different kind of logicism. As is well known, the following discussion of the foundations of mathematics after this symposium ends with Gödel's announcement of his incompleteness theorem. It's the first time it's publicly announced. It's a bit striking that this is happening in the symposium that Carnap organized. People often say, well, it's kind of funny because Carnap really didn't understand at all Gödel at the time. He just missed it. I don't think that could be right. In his intellectual autobiography, Carnap reports that immediately before the symposium, 1 month before, it was in August, this is September, August 1930, he met with Gödel. September 1930 was the Tagung. He talked to Gödel about meta-mathematics. Gödel explained to him the Gödel numbering. He told Carnap that with the help of this method, Gödel had proved that any formal system of arithmetic is incomplete and completable. And when he published it in 1931, it was a turning point in the development of the foundations of arithmetic. As we'll see, it's also crucial in logical syntax. After thinking about these problems for several years, the whole theory of language structure and its possible applications in philosophy came to me like a vision during a sleepless night in January 1931 when I was ill, like Descartes. And then logical syntax after first fourth. So, to me, it's even plausible that he encouraged Gödel to announce his result at that symposium. I'd be surprised if that wasn't the case. Well, Gödel probably didn't want to announce it until the proof was nailed down and published. And the I's and Q's were not crossed. But anyway, that's just a speculation. The project of logical syntax at this point, in any case, was well underway for Carnap, and it is this project, of course, that marks Carnap's own distinctive contribution to the debate on the foundations of mathematics. In conformity with the metamathematical methods of Hilbertian proof theory, Carnap views any formulation of logic and mathematics in syntax as a syntactically described formal system, where the notions of well-formed formula, axiom, derivation, theorem, and so on can all be syntactically expressed. In light of Gödel's recently published incompleteness results, however, Carnap does not pursue the Hilbert by 31 January, both the first and the second theorem. By then, Carnap does not pursue the Hilbertian project of constructing a proof of the consistency of classical mathematics using finitary means acceptable to the intuitionists. Instead, Carnap formulates both a formal system or calculus, conforming to the strictures of intuitionism by Carnap's lights. This is language one, a version of primitive recursive arithmetic. And a much stronger system, adequate with induction, a much stronger system adequate for full classical mathematics, language two, a version of higher order type theory over the natural numbers as individuals. For both systems, moreover, Carnap defines a notion of logical truth or analyticity intended syntactically to express the essential independence of such truth from all factual content. I said it was a version of higher order type theory over the natural numbers as individuals. No, with full quantifiers high order. That's how it differs from language one. So it's all of classical mathematics. But the individuals are the numbers, and that's a basis for a coordinate system. Okay. All right. Finally, and most importantly, Carnap officially formulates for the first time the principle of tolerance. In logic, there are no morals. In logic, kind of moral. Everyone may construct his logic, i.e. his formal language, as he wishes. He must only, if he wishes to discuss it with us, clearly indicate how he wishes to do it, and give some tactical rules instead of philosophical considerations. And as we know, the principle of tolerance then becomes central to Carnap's philosophy, not only his philosophy of mathematics, but the whole thing, from this point on. It is important to appreciate, however, that despite what Carnap suggests in his autobiography, I don't have it here. Okay, the thing about saying, in logical syntax, I finally formulated the tolerant attitude that I had all along. That's what I think is wrong. This principle now, in syntax, goes very far beyond the non-committal and neutral attitude towards opposing philosophical positions that he had maintained throughout his career. It's much more radical and much more problematic. In the first place, modern logic and mathematics had furnished the uncontentious neutral platform for Carnap in all of his work up until now. In Der Raum, as we have seen, he appealed to the logic of Frege and Russell. Now, something is wrong here. No, I just missed a so let's ignore that. So here I am. In Der Raum, as we have seen, he appealed to the logic of Frege and Russell in his chapter on formal space, to Hilbert's axiomatization of geometry, although the glitch, in his chapter on intuitive space, and to the Riemannian theory of mathematical manifolds of any number of dimensions, both here and in his chapter on physical space. Similarly, the logic of Principia Mathematica, together with elements that we now call Zermelo-Fraenkel set theory, constitutes the unquestioned formal framework for the alpha. There's Abraham Fraenkel. I emphasize him because Carnap was in close communication with Fraenkel throughout this period. Carnap, in I think the second edition of the Leer, or maybe in the first, is referring to Carnap, certainly in the second, refers to the Aufbau, refers to his conversations with Carnap, and we know Carnap and he were engaged in conversations about axiom systems and their completeness, the so-called extremal principles throughout this period, connected to his alga and axiomatic theory. So his relation to Fraenkel is very important. If you want to know more about this and his engagement with cutting-edge logic and mathematics at the time, in this wonderful book called The Cambridge Companion to Carnap, there's a wonderful paper by Eric Leck called Carnap and Modern Logic, where you get all of this. And he really was very much at the cutting edge of it, even though when he tried to prove things often it didn't work out. Though he did prove the fixed point method. Okay. Indeed, so Principia Mathematica or Zermelo-Fraenkel set theory, he doesn't distinguish. His commitment to Principia Mathematica at this time in the Alpha is so strong that Carnap confounds contemporary readers of the preface to the first edition, that is us, by appealing to the contradictions that had precipitated the foundations crisis in order to praise modern Frege-Russell logic at the expense of what he calls the traditional logic, the alter logik, as if it was Aristotelian logic that led to the contradictions, not Frege that led to the contradictions. And then, well, he does indicate what has to go on, that we have to re-examine and re-establish the foundations of mathematics. And of course, we have to reconsider logic, and we have to have type theory or set theory or something that Frege didn't have. He glosses all over that because he's just so confident that now it's right. Okay. Once again, however, Carnap's view in logical synthesis. Sorry, this is another thing. I'll make it talk. Now, however, it's precisely the modern logic developed by Frege and then Russell, together with the foundations it has attempted to provide for modern classical mathematics, that's what's at issue in the foundations crisis, although it wasn't an issue for Carnap and the Alpha. So it is far from clear now what possible neutral framework for pursuing scientific philosophy and avoiding hopeless philosophical disputes could still be available to Carnap if the logic and the foundations of mathematics aren't. I shall return to this question of neutrality in a little bit. But I meanwhile want to note a further radically new element in Carnap's syntax approach. The Frege-Russell tradition had operated with a revision of the original Kantian distinction between analytic and synthetic propositions appropriate to the new logic. While Kant had appealed to both subject-predicate containment and being in accordance with the law of non-contradiction, together with definitions, as criteria for analyticity, only a modification of the second criteria, because we don't have subject-predicate logic anymore, be in accordance with all the laws of the new logic, which are now defining logical consistency, together with definitions, is appropriate. Moreover, the laws of the new logic in the Frege-Russell tradition were supposed to be distinguished by a special kind of maximal generality involving quantification over absolutely everything, in comparison with the laws of the special sciences. If we could show that all of classical mathematics is derivable from such maximally general laws of logic, together with definitions, we would therefore have accomplished something quite substantial. For Carnap, however, the question of reducing mathematics to logic in some antecedently understood sense is now rather abruptly dismissed in syntax. Indeed, in a section about the foundations of mathematics, it even says the so-called foundations of mathematics. Whether in the construction of a system of this kind, only logical signs in the narrower sense are to be included, as in Frege and Russell, or also primitive mathematical signs as in Hilbert, and whether only logical primitive sentences are to be taken as L primitive, that is analytic primitive, or also mathematical senses, is not a question of philosophical significance, but only one of technical expedience. Incidentally, the question is not even accurately formulated. We have in general syntax made a formal distinction between logical and descriptive signs. but a precise classification of the logical signs in our sense, which can include primitive arithmetical signs, into logical signs in the narrower sense, like the Russell logical signs, and mathematical signs, which don't yet count as logic until you define them logically, has so far not been given by anyone. And so their whole problem is just dismissed. Finally, as Carnap suggests in this last quotation, the key to his new conception of analyticity is a distinction between logical and descriptive science. The basic idea is that analytic or L-valid propositions are those that are valid independently of any descriptive signs that may appear in them, and are therefore independent in particular of all empirical facts about the world. That's what he's trying to get, independence of facts, inspired by Wittgenstein's Tractatus. Analytic propositions in this sense are entirely empty of content, and as that is factual content, and as a result, Carnap holds that logical mathematical propositions are fundamentally instruments for inferentially organizing the contentful propositions of empirical science, rather than being contentful propositions themselves. That's part and parcel of their analyticity, certainly not the Frege-Russell view. He describes this conception, Carnap, nevertheless, at the beginning of his career as being derived essentially from Frege, namely as the task of logic and to supply the forms of concept statements and inferences which are applicable everywhere. The nature of logic and mathematics can be clearly understood only if close attention is given to their application in non-logical fields, especially in empirical science. And later, he acknowledges the importance of Wittgenstein's Tractatus as well, which I briefly mentioned. So he thinks that despite giving up entirely the reduction of mathematics to logic in the Frege-Russell sense, he's still capturing something important of religious doctrine. Once again, however, Carnap's view in logical syntax radically diverges from the tradition of Frege and Russell, including the Wittgenstein of the Tractatus. For not only is the formal characterization of the distinction between logical and descriptive signs, to which he refers in quotation number 17 here, which is the key to his review, language relative, and therefore language variable, but the characterization itself is subject to technical difficulties. And Carnap just quickly abandons this characterization in his semantic theory, where in this period he is basically to contend, although he would like a general formal characterization, he says it doesn't really matter, because we can simply present the distinction in the case of any particular language by enumerating the logical signs. We don't really need to do anything more than that, because we kind of know what those are. So it appears entirely unclear, once again, what the force of Carnap's new conception of logical mathematical truth is supposed to be. The key to properly understanding Carnap's new emphasis on the importance of the analytic distinction in logical syntax is to appreciate the extent to which it has nothing in common with any foundational program, whether logicist, formalist, or intuitionist. Rather, according to the principle of tolerance, the point of viewing the statements of logic and mathematics as analytic lies solely in our freedom to choose which system of logic and mathematics best serves the formal deductive needs of empirical science, not because there's a notion of truth in virtue of meaning which grounds logic and mathematics. That Quinean picture is just not common. And it ignores the principle of tolerance, and indeed Quine's picture of logical syntax, which he lectured on at Harvard, was based on earlier drafts that he was reading in Prague, where the principle of tolerance and Carnap's discussion of intuitionism hadn't yet made it in. And Quine doesn't discuss that in the lectures. Classical mathematics, for example, is much easier to apply, especially in physics, than intuitionist mathematics. While the latter, that is intuitionist mathematics, being logically weaker, is less likely to result in contradiction. So there's some advantages to classical mathematics, but there's advantages to intuitionist mathematics too, if you're really worried about consistency, and given the paradoxes and so on, it's a reasonable thing to worry about. The choice between the two systems for Carnap is still purely practical or pragmatic. And it should thus be sharply separated in particular from all philosophical disputes about what mathematical entities really are, independent photonic objects or mental constructions, for example, or which such entities really exist. Only natural numbers, for example, or also real numbers, that is, sets of natural numbers. And here, in Foundations of Logical Mathematics, 1939, in the semantic period, section 20, where I just took that quote, is called Controversies over, quote, Foundations of Mathematics. Right? Only Carnap could write a work that's called Foundations of Logic and Mathematics, but when he gets to Foundations of Mathematics, he puts foundations in scare quotes, meaning don't take it too seriously. So that's pure Carnap. So these, whatever foundations there are here are not foundations in the sense in which these controversies are arguing about what they do. Oh. Carnap aims to use the new tools of metamathematics definitively to dissolve all such philosophical disputes once and for all, and to replace them instead with the much more rigorous and fruitful project of language planning, language engineering, a project which, as Carnap understands it, simply has no involvement whatsoever with any foundation or other epistemological philosophical program. Namely, we just have to engineer the language of full classical science, and it's going to have a logical, mathematical, inferential part. We can entertain whether to use intuitions or classical logic there, but that choice is going to be purely pragmatic because of the, as it were, empirical contentlessness of that, according to him. The question is, so which is more expedient pragmatically for formulating that language? And you may not want a contradictory language if you're very concerned about that, more than the smooth calculations that empirical science wants to use. Then you could legitimately go with an intuitionist. On the other hand, if you're not so worried, because contradiction hasn't been found, and you care more about the smooth application, you can do that. That's it. That's all there is to it. But what about Carnap's commitment to neutrality in connection with the principle of tolerance? Can Carnap really dissolve the philosophical disputes in question from a standpoint that is neutral with respect to the very questions at issue? In particular, can he really dissolve the dispute between classical mathematics and intuitionism in an entirely non-question-begging way? Well, no. Although it is, but does it matter or not? Although it is not itself explicitly focused on this particular dispute, that is, intuitionism and classical mathematics, the exchange between Carnap and the intuitionistically trained logician E.W. Beth in the Schultz Carnap volume of the Library of Living Philosophers is especially illuminating in this regard. All the more so because it does explicitly involve the relation between the principle of tolerance on the one side and mathematical intuition on the other. The main criticism that Beth develops is in his contribution to the volume, it's one of the best and most interesting contributions, is that the project of logical syntax requires what Beth calls, quote, a non-formal intuitive interpretation, unquote, so that the syntax project is less purely formal and also less unrestrictedly tolerant than Carnap appears to realize. The crux of Beth's argument is that syntax is itself a kind of arithmetic, as becomes especially clear in Gödel numbering, for example. And viewed as an arithmetic, a Carnapian syntax language or meta-language may then have non-standard models, containing non-finite numbers, say non-finite sequences of expressions, extending beyond in the ordinal sense the standard numbers 0, 1, 2, ... So that in the case of physics, there may be numerals extending beyond, in this sense, beyond the standard finite numerals, or derivations may, in a sense, have more than a finite number of steps. Someone who understood Carnap's syntax language in accordance with such a non-standard model would systematically misunderstand his main inductive definitions and results, such as they are. And so, Beth argues, Carnap must implicitly be assuming that the syntax language is understood in accordance with the standard model. Further, Beth claims, we are thereby faced with what he calls, Beth, quote, a limitation regarding the principle of tolerance, unquote. For although someone who understands Carnap's syntax language in the standard way, such as presumably Carnap himself, can understand someone who uses a non-standard interpretation, the perverse practitioner of syntax in accordance with a non-standard interpretation whom Beth spells Carnap star, would never be able to understand the standard one. For this practitioner lacks precisely the standard understanding of the concept of finiteness. Carnap, in his reply to Beth, entirely accepts Beth's technical point. And accordingly, he entirely accepts Beth's claim that, quote, we find in logical syntax also concepts which, though defined in a purely way, are clearly inspired by a non-formal interpretation. Carnap suggests that he understands Beth's point in terms of the notion of an interpreted formal language or calculus in the sense of the semantical works he developed shortly after logical syntax. And in Foundations of Mathematics is the first time we see what this would look like. Carnap applies this test to one when he's talking, how much time? 5 minutes. I think I can get pretty close. Okay. Carnap suggests that he understands Beth's point in terms of the notion of an interpreted formal language or calculus in the sense of his semantics. And in Foundations of Logic Mathematics, when he's talking about an elementary mathematical calculus, this is very clear. Where the calculus being interpreted is based on the term B, a one-place functor, tending to be the successor relation, and the predicate M being the property of being a natural number. Carnap is here, moreover, appealing to a standard construction of the Frege-Russell cardinals within higher order logic presented in previous section 14, although that's not essential. But in any case, there is no doubt that Carnap is presupposing the standard understanding of the concept of finiteness, just as Beth suggests. Right, here's the interpretation. The class of finite cardinal numbers, progression of finite cardinal numbers ordered according to magnitude. Carnap just takes for granted this is the standard reading. No problem. Okay, I'm going to leave out this parenthetical thing about geometry because it's kind of short, although I love it. I hope we can come back to it. There he brings in Einstein in a beautiful way. I skipped that for now. So returning to the reply to Beth in the shield theorem, that happens in the next, I'll just show you. When he talks about the interpretation of geometrical calculi, they're treated quite asymmetrically when they are. It turns out that the interpretations are all empirical and descriptive. You can't have a logical, because of Einstein. Returning now to the reply to Beth in the shield volume, Carnap applies his semantical conception of an interpreted language to the meta-language used in both syntax and semantics. Here it is. So that's the geometrical one, sorry. There's all the Einstein. Okay. I always presuppose, both in syntax and in semantics, that a fixed interpretation of the meta-language, which is shared by all participants, is given. But since the meta-language uses English words, it is assumed that these words are understood in ordinary sense. Now, of course, the imaginary case constructed by Beth violates this presupposition of a shared common language. As Carnap himself puts it, quote, Carnap star does not use the meta-language ML, but a meta-language ML star, which, although it uses the same words and sentences, differs from ML since some of the words and sentences have different meanings. Well, no problem, I'm presupposing we're using the same words. Yet Carnap is completely in trouble by this because he is simply assuming that an unproblematic understanding of the standard model of arithmetic is encapsulated in ordinary mathematical usage. There is no deep mystery here. There is no need to puzzle ourselves over the question of how we somehow force an uninterpreted formal calculus to designate or refer to an intended model. We simply give the customary interpretation of the system in unproblematic, antecedently understood terms of ordinary mathematical language, including finite, appealing to an intuitive grasp of the standard model in any fixed sense, adds nothing at all to this routine procedure of ordinary mathematical practice. Carnap is also completely aware that there are similar cases of failures of communication possible that are more directly relevant to tolerance in syntax. Again, in reply to a classical mathematician is in this situation with respect to an intuitionist. Again, there's a failure of communication. Just as Carnap cannot communicate the standard interpretation of the concept of finiteness to Carnap star, the intuitionist cannot understand the classical interpretation of unbounded existential quantification over the natural numbers. Does this, as Beth suggests, then imply a restriction or limitation of the principle of tolerance? It may at first appear that it does. for Carnap's application of the principle of tolerance to this case poses the question in a syntactic or semantic meta-language. Here, this is from 1939, so it's a semantic meta-language. It's a language of information, as he puts it, of knowledge. Poses a question in a semantic meta-language whether to adopt the classical or intuitionist logical rules for a particular object language, the language of physics. We weigh the relative safety from the possibility of contradiction of the intuitionist against the fruitfulness of the classical rules, and we then make our choice. But if the intuitionist cannot understand the rules of the classical framework, and cannot in particular understand the necessarily even stronger classical meta-language in which we semantically describe these rules, then it would appear that our entire procedure simply begs the question against the intuitionist. In no sense do we have a neutral, shared meta-perspective for evaluating the two positions on an equal footing. This complaint against Carnap is certainly very tempting. I confess that I have myself succumbed to this temptation more than once. I now think, however, that it misses the essence of Carnap's conception, as it emerges particularly clear in the reply to Ben. Just as in the case of our understanding of the standard model of arithmetic, Carnap presupposes that classical mathematics as it is standardly practiced is well understood. That doesn't mean we couldn't have problems, but we understand that as well as we understand anything. Indeed, classical for mathematics for Carnap is a model or paradigm of clear and exact scientific understanding. And there is no way in particular to raise meaningful doubts about our understanding of this framework on the basis of independent, purely philosophical commitments. To be sure, the foundation's crisis, sparked by the discovery of the paradoxes, especially in the context of Gödel's recent incompleteness results, raises serious technical questions relevant to the consistency of the classical framework. And this is precisely why, for Carnap, we should now take intuitionism seriously in his sense. That is, we should entertain the proposal. We don't just dismiss it. To take it seriously, however, that means that we entertain the proposal, starting from within the classical framework, that we should weaken its rules to make inconsistency less likely. There is nothing in Carnap's position blocking a classical mathematician from entertaining this option or even deciding then to adopt it. Carnap has therefore not begged the question about the choice between classical and intuitionist mathematics as he understands it. That a philosophically committed intuitionist mathematician cannot understand the choice as Carnap understands it is irrelevant. That's a purely philosophical misunderstanding. For the situation in which we, in fact, find ourselves has arisen within the paradigmatically well-understood practice of classical mathematics itself. Okay, last paragraph. In 1936, at the very beginning of his semantical period, this is a conference in 1935 in Prague, the very conference where Tarski, at Carnap's urging, first made public his idea of theory of truth. And Carnap, unlike the other Vienna Circle people, got on board while Neurath and others thought Tarski was reintroducing metaphysics, and others the theory of realism. But anyway, in this paper, von der Erkenntnis der Wissenschaften from epistemology to the logic of science, the point of that was to argue that all traditional epistemological programs, including his earlier project in the Aufbau, that's an unklärer Mischung, he says, aus psychologischen and logischen Bestandteilen, including his Aufbau. That's the problem. And so all these projects must now be renounced as such unclear mixtures. Carnap at this point is decisive in explicitly breaking with the entire epistemological tradition, even in the attenuated form of the Aufbau. Wissenschaftslogic, in particular, is in no way concerned with either explaining or justifying our scientific knowledge by exhibiting its ultimate basis, whatever this basis might be, intuition, logic, or whatever. It is rather concerned, instead, Wissenschaftslogic, with crafting a new role for philosophy vis-a-vis the empirical sciences that will maximally contribute to scientific progress by contributing to the development and clarification of mathematical inferential frameworks for these sciences, empirical sciences, while at the same time diffusing all the traditional metaphysical disputes and obscurities that have constituted, and Carnap thinks continue to constitute, serious obstacles to progress in both philosophy and the sciences. Carnap's philosophy of mathematics, in the end, is thus a kind of anti-philosophical philosophy of mathematics. Or perhaps better, a new mathematical philosophy of replacement, which, in the famous words of logical syntax, aims at nothing more nor less than to take the place of the inextricable tangle of problems one calls philosophy. There it is. In German. Yet it is in precisely the way in which Carnap's Wissenschaftslogik responds to and develops out of a variety of serious foundational challenges faced by early 20th century thought, which, as we have seen, include some of the deepest intellectual problems surrounding modern, that is, early 20th century philosophy, logic, mathematics, and mathematical physics. It's in precisely this way that Carnap's project acquires its undoubted philosophical significance and force. Thank you.
Okay, yes. I see many hands and time is short. Let's see what happens.
Okay, so.
I would like to ask you a question about how to
Microphone.
explain that in logic there are no morals. And I don't want to ask it in the form, just what I'm trying to get is not to say why he was
Thank you
wrong.
very much. Just go ahead.
Okay, so I'd like to ask you a question about Carnap's claim in logic there are no morals. And what I would like to understand is how a person as smart and as serious as Carnap could have made this claim, and I would like to explain why I think he had evidence or he had reason to believe that this claim is completely unreasonable. Now, the one way to approach it is to say, did Carnap say the same thing about physics? Did he say in physics there are no morals? And I think the answer is clear that he would not have said that about physics. In physics there are morals. What morals are there in physics? The moral of not making errors. The moral of having correct theories. And I don't care now about the difference between truth and verification, but just a certain sense of having correct theories. So if, for example, I accept an incorrect aerodynamical theory, and then I use it to build an airplane, the airplane will fall.
Yeah, I would be very afraid to fly back to California.
That's right. But now, the same thing holds for logic. If when I design an airplane, I use an arbitrary game of reasoning, just any arbitrary game that someone would invent to build my airplane, if I used a game that had, say, affirming the consequent, or I used a game in which had a law of identity like PA, A is not B, therefore not PB, or something like that, then the airplane will also fall off the sky, just as if I had used the wrong aerodynamical theory. So my point is that Carnap, and now someone might say that Carnap could have said like Quine, okay, I will take this unreasonable logical game, but I will change my aerodynamics to fit it so that the airplane will not fall. But this is not the issue. The issue is that in the same way that there are constraints on our physical theory, there are also constraints on our logical theories. And these constraints mean that there are morals in logic. And this is something, I think, that especially someone like Carnap, who was so careful about being serious and being responsible in theorizing, and who rejected metaphysics because there were no constraints on it, and because it was so unserious and so irresponsible, could think that in logic is fine. In logic, we don't have to be responsible. In logic, there are no morals. I wonder what you think about that.
That's a good question. Okay. Well, let's read the whole thing, just to be clear. In logic, there are no morals. Everyone may construct his logic, i.e. his formal language, as he wishes. He must, if he wishes to discuss it with us, clearly indicate how he wishes to do it and give syntactical rules instead of philosophical considerations. So, after saying there is no morals, he does give a must, a philosophical must in what if you want to talk about logic. That's just the beginning, You asked a long question, let me say, just to start, let's just read the whole principle. It's not in logic there are no morals, it's all of that. Okay. Point number one. Now, that may lead to questions whether there could be morals in logic, say, that were neutral with respect to foundations, say primitive recursive arithmetic, and maybe some kind of proof theoretical rules. Sometimes in Carnap you get that idea. Because that would be what syntactical rules instead of philosophical arguments. So that's one way in which you could have constraints that would be okay. What he's really wanting to do with this statement is get rid of the philosophical dispute associated with the foundations crisis. That, he thinks, is in the end not serious. Why is it not serious? Because it isn't about building bridges, airplanes, or the progress of science. Okay? That's what he's worried about in the principle. Okay, point number two. Now, of course, it's also central to Carnap that there is a big asymmetry between the logical part, the L rules, and the P rules. Right? The P rules have content, they have factual meaning in a formal sense, while the others are contentless. And they have some of the status of tautologies that Wittgenstein has, although for that Carnap says, well, what that means is there is a kind of freedom relative to factual truth that is not the case in physics. Point number three. Finally, there's still a constraint, because since what we want to do is build bridges, I mean, he thinks, of course, we want to have relativity theory, we want to have quantum mechanics, we want to do all that. And so it's really fruitfulness in empirical sciences that in the end is the criterion for all that's happening. It's just that it operates differently for the P rules than for the L rules. For L rules, there is morals, namely, if something happens with the L rules and you get false predictions, you have to make a change to the language. However, you have choices. You could give up the observation sentence, you could change the L rules, or you could change the P rules. And changing the L rules and changing the P rules for him are essentially different kinds of changes, because one has to do with factual truth and the other doesn't. So his picture is not an unconstrained response. His condition is, look, we are serious scientists. Right? And the danger to serious science is the best scientific philosophy of the time, foundations of mathematics, right? He's engaged with a fruitless and unresolvable metaphysical dispute. This is the danger to serious science. So how can we, as scientific philosophers, hold that at arm's length? The principle of tolerance is intended to do that. Not to say anything goes in science. That's the opposite of what he wants to do. Maybe that's enough for now. Maybe we should continue this, because this is a very serious dispute.
Interesting and long question. Let's move this way, please. I will let you. But we also need the microphone to move to Bill. Please.
Yeah, it's a very interesting history, but there's a funny thing that happens. For a while, it's all about call it the epistemology of space-time physics, and then Brouwer meets the Vienna Circle, and then it's all about logic and mathematics. I mean, of course, Brouwer himself abandoned geometry, but it's interesting that given Brouwer any kind of interest in Brouwer's views, or generally constructive views of mathematics, that something wasn't tried in the direction of a constructive space-time theory. I mean, it's really something in the new millennium that's actually arisen. I mean, space point-free topology and point-free geometry. But it seems that it would have been very natural for it to have happened there. But instead, they just sort of gave up thinking about physics and only started thinking about logic and foundations of mathematics.
Excellent question. Well, he didn't exactly give.
Well, I meant, what is your history? I don't know what actually.
No, see, because I glossed over the crucial point in Foundations of Logic and Mathematics, where he distinguishes sharply between the interpretation of geometrical calculi and interpretation of arithmetical ones. This is very important, because the geometrical calculi have a factual interpretation in their standard meaning, and therefore what happens is that's an empirical question, as Einstein has showed us. Okay? So he's still importantly connected to physics. Carnap would have no trouble or problem with attempts to develop constructive space-time theory. He would be very interested in that, especially if it led to somehow a better, simpler way of doing analysis in synthetic differential geometry. He would have no problem with that at all. That wasn't being developed, or if it was, Carnap didn't know about it. But his tolerance standpoint would have no problem with that whatsoever. Again, what he wants to do is prevent the late 20s, early 30s foundations crisis from getting in the way of making progress in mathematical physics by focusing our attention on whether numbers really exist, and if so, are they mental constructions or what. This is kind of a caricature, but that's how he sees it.
I'll try to give an opportunity to everyone. Over here.
It looks like the distinction between different attitudes toward philosophy of mathematics begins with answering what numbers are, or where do they come from. And I want to suggest a very simple thought experiment about numberless perception of the physical world as we know it. Suppose there is an intelligent being that has a very accurate vision, so it can see individual atoms. So they can see atoms moving around, but it's very difficult to count them, or impossible, like a school of fish, to count a school of fish. And so the perception of such a being will be kind of a density function about the world, but the word function is even wrong here because it's fluctuating continuously. So it cannot talk about quantities or states, but if it is intelligent, it may be able to predict where does the fluctuation of the density function goes. Of course, describing more deeper the situation, I will be constrained by my human cognition and by my language.
But also by the physics of the elementary particles. As Bill pointed out, we don't have well-defined individuals at all there.
Okay, but okay.
So the idea of these discrete individuated things breaks down for the elementary particles.
So my point of view that that being cannot make.
Even God can't
Sorry?
count them, as it were, because they're not discrete individuals.
Okay, but what I want to say is that there is a possible description which will be partial because of our limitations of numberless perception of the physical world, and what I want to, of course, to argue is that maybe this is a sign that it is not impossible to claim that mathematics is just in the human mind and nothing else. It is just by our senses. Actually, I wrote about it like 20 years ago, but 10 years later, there was a book, The Number Sense, that argue from a biological point of view that that animals can somehow calculate with small numbers. So maybe this is not just human endeavor, but also earthly, you can say. But it goes even further, like cause and effect.
Yeah, we have other questions.
Okay. You don't want to. Okay, please, over there. Yeah. Just a minute, please.
Yes, I think one shouldn't praise colleagues too much. But in any case, I have enjoyed this kind of thing.
Well, I think you should praise
But in any
Carnap
case,
too much.
I thought you gave a very excellent survey of Carnap's development. And as a person, I think Carnap was very sympathetic, and this idea of tolerance and so on is a very fine one that we should all have in philosophy. But there are some objections I have. One is the view about that you have in number 8 about the undigested experiential given. That seems to be a point that Carnap never really, during his life, came back to in a satisfactory way. And I'll try to include a little bit about that tomorrow morning in what I'm going to say. But then the other point is what I'm going to get back to, and that has to do with the tolerance thing, because it started out very much as a discussion between Quine and Carnap concerning the epistemological relevance of the analytic-synthetic distinction. Because Quine, of course, thought that it had no epistemological relevance. And what Carnap did was to modify that distinction in such a way that you get these different choices of languages and so on that you describe. But nothing is left of what was the original problem, namely, what is the epistemic difference between the formalisms that you use and the rest of the language. So it seems as if the tolerance has really gone so far that nothing remains of the original issue. But I wonder whether you might say that there is something that remains.
Well, part of my point was that Carnap abandons asking about the epistemological difference. Right? That's the point of Fundera-Kentis theory, sort of Wissenschaft. So, and Quine, of course, holds to that, and this is one reason why they talk past each other. But Quine does not understand, he cannot believe that Carnap is saying, I'm abandoning the epistemological issue. And Carnap, since he has abandoned it, can't understand what the issue is between him and Quine. Right? But the fact is, in this sense, Carnap is more radical. Quine is more of a traditional philosopher in this sense, and that's why Quine is a figure in traditional foundations of mathematics, in the sense that's similar to us. Carnap is dropped out. He's dropped out of that. And he thinks, because the foundations crisis in mathematics is such a danger, right? And then he has the same thing in 1950 about nominalism, about abstract entities. He says, scientific progress, when are we going to learn the lessons of science and adopt tolerance and not worry about this, right? So that's Carnap's point of view. He is terrified that metaphysical, philosophical disputes, which are irresolvable in principle, and people are always talking past each other, unlike in science, are going to get in the way of science. This is what obsesses him, right? And he can't believe that his good friend Quine could fall prey to this disease, right?
Charles, please.
Yes. I was worried about just this matter of the irresolvability, because clearly one of the disputes that was moving him in the period when he was working on logical syntax was the conflict over intuitionism.
Yes, exactly.
But clearly, one side won.
Yes.
So in some sort of way, it was resolved. I think it probably wasn't resolved by philosophical arguments, so you can say in favor of Carnap that although it was resolved, at least I would say it was resolved, and I think many other people who think about the foundations of mathematics would say that it was resolved. Carnap does have the point that it was, you might say, the development of mathematics rather than philosophical arguments that resolved it to the extent.
And thereby freed it from the philosophical arguments. And I guess this has, I know little about this, but my colleague Richard Mintz has told me about it. And according to him, it's this distinction between hard and soft analysis that now allows both sides to be there. Is that what you have in mind? So that feels to me like a pretty Carnapian type of resolution. That is, mathematics itself has progressed so that there is a place for both viewpoints. Both are legitimate, depending on what it is that you're looking for.
Yeah, I
It's
think
not, of course, it isn't resolved. It is one important point here is it's resolved in pure mathematics. It's not resolved by empirical fruitfulness. It's kind of, well, mathematics has found it fruitful that we can, analyze proofs classically, or we can look at combinatorial strength and these kinds of things. You can do both of those things. So it's resolved in pure mathematics independently, so it doesn't fit with Carnap's idea that the be-all and end-all is empirical science.
Yeah.
So in that sense, it is undermining Carnap. And I personally would be happy to see Carnap undermined that way.
well, that's a point of agreement with Carnap line, I would
Yes.
say.
Okay, I will give just one last question, and I apologize with other people who wanted to ask. Time is pressing, and please.
Yes. I too admired the exposition. I would not say it was a complete story about Carnap. It was very incomplete because with the beginning of the period where he was engaged in semantics, he was also engaged in confirmation theory. And confirmation theory, after a while, overtook everything else in Carnap. And I think some of the things, as you say, were neglected, especially on the epistemological side, were very much taken seriously in this period. There's no need for me to go into an exposition, I couldn't right now, exposition of what Carnap was about in connection with these things. But I think everyone here should remember, I think you're so focused on philosophy of mathematics to forget that there was this period in Carnap, and that was the last period and it lasted for a couple
25 years. 25
yeah,
years.
a couple of decades of that. It was very serious. He got engaged with Popper. Got engaged with my own teacher, Ernest Nagel, in that very volume, pretty nastily. So Carnap is not the tolerant Carnap in that particular exchange.
That might have made you more fond of him, no?
Huh?
But that might have made you more fond of him.
But as a matter of fact, this was this should be kept firmly in mind in thinking of this. The rest of the history I reverberated with much joy with much of what you were saying. This is a very serious omission. I should protest.
Well, that's because the title of my talk is From Intuition to Tolerance in Kant's Philosophy of Mathematics. And I mean, I have a serious point because I do think the confirmation theory stuff is extremely important. That is what Wissenschafts Logik was for him for the last 24 years of his life.
That's exactly
it was about choosing the right inferential, now that means statistical framework for an empirical science where statistical methods are increasingly important in all branches of empirical
I
science.
think this gentleman here was partially interested in that. We talked about density functions.
Yes, that.
Yeah.
So I agree, and I think that's an excellent example. I mean, there he tried, the dispute he tried to dissolve was what is probability really? Right?
Well, you wanted to know how to use probability.
He wanted to know how to use it, but he didn't want there to be disputes between subjectivists and objectivists that would get in the way.
What he did was bifurcate. So there's
Bifurcate.
Probability 1, probability 2.
That's exactly.
But for him, the chief concern was probability 1, precisely because it was going to go around with this issue.
Yeah, no, I agree. And in a fuller story of Carnap, that has a very central role to play. In the wonderful volume called Cambridge Companion to Carnap, there's an excellent piece by Sandy Zabel on that work. Well, to my mind, it's excellent, but really, Frank, I don't know a whole lot about that subject, but I agree with you that it's very important in understanding Carnap's program.
This is a point of agreement, I think.